So today we're going to be talking about stoichiometry. So stoichiometry is just, loosely speaking, it's using the balanced chemical equation to derive relationships between different compounds that are in the equation or in the reaction. So I'm going to be using these 4 steps for stoichiometry. So whenever you're doing anything with stoichiometry, your first step is always balance the equation. If you're not sure how to do that, I do have a video up about balancing the equation, or you can talk to your teacher if that for some more insight if that video is not making sense to you. So the second step is to convert your given unit to moles. So generally this will be something like, it'll say, how many, if you have such and such grams, how many other grams would you make of something else? We'll get some examples later, but you'll convert your given to moles. Number 3 is calculate moles wanted. This here, you're going to be using molar ratios in the reaction. We'll get into that a little bit more later. And then number 4 is you convert moles wanted to unit wanted. So just convert it, whether it be from moles to grams, or from moles to milliliters or kilograms, or whatever the problem is asking for. Okay, and I would highly recommend that you write these down and you memorize them, because if you know these, then it will really help you. So it's 4 steps, 16 words, really simple, but it will help you a lot on exams and quizzes and just for general knowledge. So let's look at an example. Okay, so I wrote down an example here. So the example says, when antimony is sprinkled into chlorine gas, antimony chloride is formed, and it gives an equation that looks something like this. So we have antimony, that's Sb, and that's solid. And then we add chlorine gas. Well, chlorine is found as Cl2, and then this goes to form antimony. Let's see, that's just Sb, and then chloride, like that, and that is solid, and this is a gas. Okay, so that's our equation. So the question is, how many moles of chlorine are required to produce 4.09 moles of antimony chloride? So we want to know, we want 4.09 moles, and we want to know how many moles of this. Okay, so let's go over this. So our first step is to balance the equation. So let's see, is this equation balanced? Well, we have 1 antimony, 2 chlorines, and over here we have 1 antimony and 3 chlorines. So it's clearly not balanced. So how can we balance it? Well, if you have something like this, where the element is only in one place, a lot of times what you can do is just multiply by the other one's subscript. So we can do 3 and 2. So now this is 6 and this is 6 chlorines. And then let's see, now we have 2 antimonies over here. Well, we can remedy that to balance it by just putting a 2 there. So step 1, balance the equation, is done. Okay, so now we want to convert our given to moles. Well, we're given that we want 4.09 moles. And this is a really easy way to convert it to moles because it's already in moles, so we don't have to do anything. So that's 2 steps already done. Okay, so now we want to calculate moles wanted. So we use molar ratios for this. So what we do, we take, for any time we want to change our units or do a conversion, we use what's called a conversion factor. So what we do is we take our given unit and then we multiply it by what we want over what we are given. And then that will give us what we want. Because this will cancel out and this will cancel out. Okay? So in this case, actually I'm going to leave that there for now. We're given 4.09 moles of antimony chloride. Okay, so then what do we put in here? Well, in a chemical equation, once it's balanced, we can use what's called mole ratios. And that's just by using the coefficients of these numbers. So, for example, we know that for every antimony chloride, we have 3 chlorine. Oh, that's an S. I don't know why I wrote that. We have 3 CO2 for every 2 antimony chloride. So this is a 3 to 2 reaction. So then we can just multiply it. Oh, and this should, I'm making a mistake here by not saying moles. So we'll just add that in there. So this cancels out with this, so we'll just be left with moles of chlorine. So let's do the math here. So we have 4.09 times 3 divided by 2. So that gives us 6.135 moles CO2. Let's see, and that's what we, so that's step 3. Now step 4 is convert moles wanted to unit wanted, but initially we were asked to find how many moles. So we're done with that step already. So that step would be normally if we wanted to find like how many grams we needed. So that's the end of that, almost. That's the end of the stoichiometry, but now we need to look. We were given this number here. This has 3 significant figures. Well, down here we have 4, so we need to round to 3. So let's see here. So this is 6.14 moles CO2. And I would recommend waiting to the end of your problem to round, because sometimes by rounding it in the middle, you can get what's called rounding error, which is when your answer differs from what the answer should be because you rounded midway through the calculation. So this here is a mole to mole conversion. We took a number of moles of the antimony chloride and converted it to a number of moles of the chlorine gas. Let's do one a little more complicated. All right, here, I guess I will stand out of the way so you can see what's going on in full if you wanted to take notes or anything like that. So, okay. Okay, so now let's do another one. So we can, I'll write this one out so you can keep track of what I'm solving for. You know, how many grams of antimony chloride could be produced from 323.6 grams of chlorine gas. Okay, so let's solve this. So your first step, balance the equation, which we've already done. So that's step 1 is done. Step 2 is to convert our given to moles. So what are we given? We're given that. That's our given. So let's convert that to moles. So how do we convert to moles? Well, we can look, let's say I have a periodic table here. So if you look on your periodic table, I doubt you'll be able to see this on the camera very well, but underneath the symbol, there will be a number. That number is the atomic mass, or the molecular mass for if you're using a mole of it. So this is either the mass in grams per mole, or it's the mass in atomic units per atom. But you can just think of it as the mass in grams per mole. So it's saying that there's 35.45 grams chlorine, or grams of chlorine in 1 mole of chlorine. Well, we have, this is CO2, so we'd have to add, so let's say the molar mass of chlorine equals 35.45 grams per mole. So we have 2 chlorines per our molecule, so that means we have, let's see, that would be 70.90 grams per mole. Alrighty, so, and this here, we put whichever one we need to be on the bottom, because you can think of this as like 70.9 grams chlorine equals 1 mole chlorine. Well, and then you can either divide by moles, and this will equal 1, or you can divide by grams, and this would equal 1. So you can multiply by either one over the other, and it would just be like multiplying by 1, which wouldn't change the value. So that's why we can do that, whichever one we want. So we want our grams to cancel out, because that's what we're given. So we're going to put that on the bottom, 70.90 gram CO2. And that's for 1 mole CO2. Okay, so I'm going to erase this. Okay, so then this equals, let's use a calculator for this. So we have 323.6 divided by 70.9. So this equals 4.564. And I'm going to add a couple of sig figs here at the back, just so that we don't get any rounding error. And then at the end, we'll round to the proper number, which is 4 sig figs. Okay, so now we've converted given to moles. Oh, and this CO2. So now we want to calculate our moles wanted. So how we do this is we just take this times the mole ratio with what we're trying to get to. So this is step 2. Now step 3 is calculate moles wanted. So we can say, well, we have 4.56417 mole CO2, and we're trying to find the amount of the antimony chloride. Well, let's see, we can see that there's 2 mole antimony chloride for every 3 moles of CO2. Okay, so then we just plug this into the calculator. So we have 4.56417, and then we're going to times that by 2, and then divide by 3. So we want 3.04278 moles of, let's see, SbCO3, antimony chloride. Okay, now we need to convert this to grams. So, in case you're not sure about how to get the molar ratios yet, let's go through that really quickly. I'm going to do it in a different color because I'm going to start running out of space here. So I'm just going to do it in a different color in this area here. Okay, so this is molar mass of antimony chloride. Okay, so we have 1 antimony atom, so that's 1 or here, let's write this in a little way that it's a little easier to see. So our total mass that we get from antimony is the number of antimony atoms, 1, times the molar mass of antimony, which let's see, where is antimony? Antimony is right here. It's a pnictogen. So let's see, we have 121.8 grams per mole. And then chlorine, we have 3 times 35.45 grams per mole. So if we take those numbers and add them up, then we'll get our SbCl3 equals some number. I should have solved this beforehand, but I didn't, so we'll just do it right here. And plus 3 times 35.45. So this gives 228.15 grams per mole. Perfect. Okay, so now that we have that, we can do step 4, which is convert our moles wanted to unit wanted. What's the unit that we want? Is grams of antimony chloride. So step 4, we'll take this number here, our moles wanted, 3.04278 moles antimony chloride, and then we are going to times that by our molar ratio. So we have 228.15 grams antimony chloride per mole antimony chloride, which will give us, let's see here, so we have 3.04278 times 228.15. So that gives us 694 points, and I'm going to round to 4 sig figs, so 0.2 grams antimony chloride. Okay, so let's see, I'll stand out of the way so you can see the board. So our first step, here I'll write that over here. The first thing you need to do, and this is an absolute essential, you need to balance the equation every single time. Don't assume that it's balanced, balance the equation. From there, you can then take your given and convert it to moles. If your given's already in moles, that's good. You don't have to do as much work. Then you take your moles and you convert it to the moles of what you're trying to find using the molar ratios, which is just the coefficients, and you arrange them so that they cancel out the unit that you're trying to get rid of and leave the unit that you're trying to keep. So here, my moles chlorine canceled out and left with the moles antimony chloride. Same up here, grams chlorine, grams chlorine, and then mole SbCl3, mole SbCl3. And then, so after you use molar ratios, then you just convert your units using dimensional analysis, which I believe I have a video on that, or it's covered in the chapter 1 material, I believe. So that there is stoichiometry. I know it seems like it can be a lot, but it's generally not too bad. You can kind of think of it, another way to remember the 4 steps is you start with like some grams, and you go to moles, then you go to moles, then you go to grams. And this is grams given, wanted, and wanted. So you can go from a gram unit to a mole of the same thing. Then you use the mole ratio here to convert to your moles wanted, and then you just use dimensional analysis to get to your grams wanted. Alrighty, so I hope that helps with understanding of stoichiometry. If there's any questions, please feel free to leave them below, or you can email me to set up like a Zoom meeting if you wanted me to help work through some problems, like some examples and that type of thing. Stoichiometry can seem intimidating. I know it looks like there's a lot of math, but if you look at what's happening, they're all pretty simple computations. It's just setting it up that you need to get right, which is not too bad. Just make sure you practice. Yeah, and if you have any questions, please ask, because this is very, very, very important stuff. It's used all throughout chemistry, all throughout industry. Anytime that you make anything, chances are it's with something that was produced using one of these methods. So, all right, I hope this helps. Have a good day. I'll talk